So, I think we start with F on Thursday. This is second block, correct? What do you guys have in block F?
Religion.
Econ.
Who has math? What else?
Econ.
We have a major history project that we're introducing on Thursday
In block G?
in F.
In F. So the major history project is due in block F?
Yeah,
Are you presenting it?
we're doing it. It's like an in-class assessment.
So you're working on it in block F?
Yeah, but she's explaining it, like she's introducing it and explaining it. And she said that that's like a really important day and that we shouldn't miss it.
Who's your history teacher?
Islam.
Man, I got econ up covered.
Well, I just talked to Mr. Shoemaker, and I said, if you guys could get your act together, then those of us who actually have tests can schedule them. They said, well, it was a mistake. It was a mistake, but the period 2 is supposed to start at 10:30. And there is no recess. What do you have in block H?
Physics.
Pre-calc.
English.
So one at a time.
Physics. Pre-calc.
Anything else?
English.
English with whom?
Trent.
Because this room's empty in H. Lunch break goes from 11:45 to 12:35. Sorry. 12:45 to 11 to 1:35. Yeah, so that's a 45-minute lunch break. So those of you in block G, is it possible that you could get out of G a little early?
Huh?
This is block G.
Or block H, is it possible that you could get to H a little late?
Yeah.
And H is pre-calc?
We have a quiz for pre-calculator.
We can take it
Even on a
later.
shortened block?
We can take it later in the class. It only takes 20 minutes.
The quizzes don't take a whole period?
Crazy timing, bro. Actually.
Who couldn't get, like, is it possible that your block H teacher would let you come in late?
Yeah.
Probably.
Like if we do it like a regular period on a late start is 10:30 to 11:35, so that's 65 minutes. That's only 10 minutes shorter, right? So would the world end if you went to your teacher, assuming they don't change it? Like I mentioned to Mr. Shoemaker, we don't need a late start. The late start would be for department time. We did that on Friday. We had all day department time on Friday. We don't need it again on Thursday. He said, yeah, well, it's on the schedule. Well, not on the schedule you guys posted downstairs and in front of the window. So he said, we'll talk about it. Well, he doesn't have a lot of time to talk about it. So in the event that it's still a late start for no real reason, and you went to your teachers today, and asked, would the world end if you got there 10 minutes late? What do you think they'd say? Would that be impossible? Even if you have to start a test late? Now, ideally, finishing a test and starting a test isn't a great idea, but if the test is only going to take 20 minutes, none of you would have trouble finishing it, right? It would only mean 10 minutes. And this is the only block that it would be an issue. Because block E, which is the last block of the day, could start early at lunch and then end at a regular time or go into overtime. I just want to give everybody the same 75 minutes. And with the first block, we would just start before 9:15. So I can do the 75-minute front end and back end. Yours is the only block that's goofy. Okay? Now, I'm still keeping my fingers crossed that the admin team does finally get their stuff together and figure this out. They haven't been for a long time, but it just makes it very difficult for those of us that have rigorous courses and full period tests to do that and give those when they don't seem to know what they're doing downstairs. Just in case, if you could go to your block H teacher, just in case, and ask, in the event that we do in fact have a late start on Thursday, if it would be okay if you showed up 10 minutes late. You may not need 75 minutes. You might not. But if you do, I don't want people running out of time because they couldn't get the schedule properly done downstairs. Now, could we wait till Monday? We could, but then if we wait till Monday, the odds of me getting it marked and back to you before the report cards are very slim. And plus, we can't wait any longer. We're already behind. So, if you could go to your teacher and just ask that question, would it be okay? Don't tell them you're going to show up 10 minutes late. Just say, would it be okay if on Thursday I arrive to class 10 minutes late? I am assuming you guys can't start it early based on what we said earlier. In other words, F would be the block that you'd have to leave early to start it early. Yeah.
I was wondering if there'd be a possibility for like some of us to leave F early and take it. Because I know some of us have classes.
For block F,
Yeah. Because some of us have classes like econ.
how many could leave F early? And what's in F again?
We have
Religion.
econ.
Strength and conditioning.
Religion.
Okay, so religion, you do nothing? What, when you don't do nothing, what do you do? Do you always do nothing?
It's usually just like an assignment. Like there's no actual like teaching, like physics and pre-calc. Like you're actually getting taught in the class, obviously.
But what happens in religion? Really?
Jack
Yeah.
happens in
Is
religion.
that all religion?
Pretty much.
Is that what block F is?
Yeah.
For all of you?
No,
No.
econ. Some of us have econ.
We, some of us have history that we can't miss.
You can't miss. So you couldn't get out of F early, but could you get into H late? That's gonna have to, you have to talk to your teacher, but those of you that apparently do nothing in block F would not have a huge problem with getting out of that early. Or maybe a more diplomatic way of saying that, you would complete whatever rigorous assignment you're given in H early, or given in F early, so you could get out early. What happens in religion if you don't do anything? Who teaches religion, by the way?
Power.
And you don't, do you do anything religious?
Yeah.
It's just like assignments.
So what's a typical assignment, if I could use that word
You
loosely?
have a reading and then you just answer questions about the reading or like a video we watched in class.
But no teaching?
No. There's some teaching, but it's like
Not even for ours. It's just
yeah,
read.
for Gelsky.
Yeah, just read and
Okay.
write. That's all it is.
And this is the same power that does advisory, correct? I'm not gonna connect those dots, you guys probably can. Okay. Well, you see now, I want you to miss F. Could you like skip F entirely?
Yeah.
I'm not gonna ask you to do that, but,
I'm okay with that.
okay, maybe, again, I'm hoping downstairs they get their act together, but if they don't, then whoever can leave F early can start the test early. Whoever can get to H late can start at the same time and just stay. Now, that's assuming, of course, you need 75 minutes. You might not. You might not. But I don't want their mistakes downstairs to be problems for you guys. Okay? Yeah.
If we come in early, will we interrupt F block's chem test?
We'll find room. We'll find room. Okay? I don't think so because F would be starting early. F would have an early start. So the room would be empty. We're not gonna start at 9:15. We would probably start at 8:45 and they'd be gone by, yeah, they could probably start at 8:45 and be gone 10 minutes before you guys ever show up. All right? Block F would end at 10:25. Sorry, no, it ends at 9:20 to 10:25. So if they start at, let's say they even start at 9 o'clock, they'd be done by 10:15. If you guys started at 10:15, that would give you 11:35. That would give you, 10:15, 11:15, 11:35. That's more than enough time. So they would be gone before you guys showed up. And it's only, you only have to show up 10 minutes early because then you get the full time, right? So no, I can take care of that. It's just the manipulating the schedule. Okay? And I'll probably end up putting something on Google Classroom. All Mr. Shoemaker said is we'll talk about it. Well, it's Tuesday. Like, are we gonna talk about it today or when, right? Anyway, I suspect they're not gonna do anything. I suspect they're just gonna leave it as it is because that's another topic. But if I have to fix it, I'm gonna fix it, and that's the only thing we can do. So apparently the religion end of it is covered. And entering H late isn't the end of the world because the test you're writing might not take the full period. Do you get the full period if you need it or no? But it's a test, really. And they only take 20 minutes?
Quiz.
A quiz, okay. And who's your teacher?
It's harder.
So would that be considered a reasonable ask in your opinion?
Yeah.
Okay. Could one of you make that ask, maybe at lunch, and then get back to me? Because then the problem is kind of solved. The front end and the back end I can take care of, but this is, I don't want to goof you guys up too. And I don't want to make your teacher angry at you, that's never a good thing. But again, none of this is your fault. Yeah. People ask me, why do I want to retire? Oh, I don't know. All the parents at the parent-teacher interview said, no, you can't retire till you've taught my son or daughter can't talk. And I'm diplomatic, but I usually think, yes, I can. I'll miss you guys.
Yay.
So, little heads up about the test. There's a multiple choice and written response section as per usual. There are 15 multiple choice questions. Not a lot. There are 5 written response questions. The first written response question is section 4.1 and 4.2 combined, to the extent I was able. Meaning, 4.1 is just about balancing equations. But 4.2 is about classifying and predicting products. So if you remember near the end of Sherry's 4.2 questions, she gave you names of the reactants and that's it. And then from that, you generated balanced formula equations. That's what number 1 is like, okay? So I'm connecting as many dots as I can in 2 sections. Now, there's more than one of those, but that's what question 1's about, okay? Question 2 is, remember we didn't do section 4.3. Question 2 is a question taken from section 4.4. That's the energy section. Do you remember when I was teaching that, near the end of that section, I said, gee, this would make a good chem question? Remember that? Good test question for the chem test? Remember that? Which one I referred to? There's a clue, okay? You're not gonna have to draw graphs or interpret them. But the detail I went through on the board, remember the 2 diagrams we drew for exo and endo? There was enough information on both of those that would lend itself well to a multiple choice for you. But you're not gonna have to draw either of them or label either of them. But the information on there, you know, like activation energy versus energy release, when delta H is positive, when delta H is negative, that kind of thing could be worded into a multiple choice. But it won't be, the graphs won't be on the written response. Question number 3 is section 4.5, straight stoichiometry. No limiting reactant, no percent yield, no percentage purity. So it's straight stoichiometry. I might give you a balanced equation, I might not. If I don't, obviously you need to generate one, right? Question number 4 is limiting reactant, and I'm gonna break it up into 2 parts. I will say, you got this much of this, you got this much of this, A, determine the limiting reactant. And when you do that, I wanna see AMR versus RMR. And then I wanna see a statement explaining why you decided what's limiting. So as AMR is less than RMR, or as AMR is greater than RMR. Therefore, this is limiting. I need to see that. So don't do it the way Sherry does it. Then part B would effectively be just straight stoichiometry. Use the limiting reactant to determine how much of this you can make, or how much of this will be left over, that type of thing. Okay? Question number 5, the last of the written response question, will be either percentage purity or percentage yield, but not both. And I'm not gonna mix percent yield or percentage purity with limiting reactant, okay? So nothing on this test will be a surprise. For the reaction types, remember all the types we talked about. And remember what was different about our grade 11 discussion than grade 10. Remember, there's 3 types of double replacement. One of them we call neutralization, one of them is precipitation, and then the last one is where we react an acid with a carbonate salt. Remember I said predict products and balance it as carbonic acid, H2CO3, but then replace that number of carbonic acid with the same number of water and CO2. And that was reaction number 7, hydrochloric acid and sodium carbonate. Remember that? All you saw was bubbles. The other type of double replacement where 3 products are when a base reacts with an ammonium salt. I would have put that in the lab too, except I didn't want to fill the room with ammonia. Okay? But that's where you balance it as ammonium hydroxide. straight double replacement, and then replace however many ammonium hydroxide you had with the same number of ammonia, NH3, and water. Okay? So, I think that's as clear and generous and kind and gentle a test outline as I can give you. Now I'll open the floor up to you, yes.
Does the acid with bicarbonate and the base with ammonium salt, do they fall under the same category with like the third type of double replacement?
There's still double replacement, but, yeah, in terms of what to label it as,
Yeah.
I would just call that double replacement generating a gas and water. Okay? Yeah. Yep.
Can you go through, question 1 of the practice problems on page 227?
Page who?
227.
Okay. Which practice problem? Okay. Thermite reaction, that one's extremely exothermic. Inside thermite's a mixture, okay, there it is. The only issue there is that both of the products should have L's after them. If 2.44 grams of 95% pure aluminum is reacted, how many grams of aluminum oxide can be produced? Okay. So if I use all 2.44 grams, is that all aluminum?
No.
So how much of that 2.44 grams is actually aluminum?
95%.
So if you multiply 2.44 by 0.95, that tells you the mass of aluminum you're starting with. Yeah,
On the test, your calculation is 1.5 or 95%.
same thing, doesn't matter, doesn't matter. But notice that 95% pure is 2 sig figs. So your answer should probably be the 2. So basically, you can't start the stoichiometry till you know how much aluminum you really have. From then on, it's straight stoichiometry. So 0.95 times 2.44 is the grams of aluminum you start with. Then grams aluminum to moles aluminum to moles aluminum oxide to grams aluminum. All you have to do is times 2.44 by 0.95, and that starts the stoichiometry. Okay? And I don't know what the answer is, but it should be the 2 sig figs, I'm pretty sure. Yep.
Do you want us to put states in our equation?
In some cases, it should be obvious. So for example, every ionic compound by itself is an S, solid after it. Hydrogen's a gas, oxygen's a gas, nitrogen's a gas. Carbon dioxide's a gas, water's a liquid. For precipitates, whether they're solid or not, if I expected you to know that, I would have to give you the solubility table. If I don't give you the solubility table, then no. Okay? And if you're doing a question on the test and you're not sure, ask me and I'll tell you. Okay?
So we won't get any marks off if we don't put like solid or anything? Or will we get marks?
Probably not. No, probably not. Like, if you had to predict the precipitate, technically I should give you the solubility table. Okay? Now, for your lab, there should be no confusion because you got your workbook, go to page 363. What are the 2 products? Which one would have to be the salt? And that one you probably don't need your solubility table. But if I expect you to do states for everything, I would have to give you the solubility table. Also, you won't have to memorize the activity series. If you need it, I'll give it to you. You have to know how to use it and when to use it, but I wouldn't expect you to memorize it. That's just data, all right? Yeah.
So based off of that, then we won't have the questions of like, will this reaction proceed?
If I give you one of those, I better give you the activity series, right? Yeah. But I'm not gonna say, hint, check the activity series. Remember, you only use it for single replacement reactions, and then any element above another will replace that element underneath it from a compound. Okay? And metals only replace metals, non-metals only replace non-metals.
When we're writing formula equations, do you want us to include energy in it, like on either side, or is that only for thermochemical?
For the lab report, I do. So in other words, if a test tube got really hot, then energy's a product. If you needed a Bunsen burner to make the reaction go, then it's endothermic. Then energy goes in the reactant side. But if you didn't feel an energy change, don't pretend you did. All right, just go with your observations. All right. Some of them you can't tell. Yep.
If we're doing like energy change equations, will the value of the energy change be provided, or do we have to try and find it? Like,
Say that again.
only in or something, when we talk about, change?
Like thermochemical or delta H.
Yeah.
How would you find it if I didn't give it to you?
I wasn't sure of that.
You think I'd do that? Yes?
Yeah.
No, God no.
Okay.
What do you think I am? I wouldn't do that. Guess the heat of combustion for propane. Good luck. Oh, you didn't memorize that? I can't do that. What else?
What's the difference between enthalpy and delta H?
Delta H is the net change in enthalpy. Enthalpy is just potential energy that's stored and can be usually absorbed or released as heat. That's enthalpy, okay? It's really just chemical potential energy. Delta H is the net change, which is enthalpy of products minus enthalpy of reactants. Yep.
On page 225, practice problem 3, can you go through how to do the excess reactant? Because I tried it a couple times and each time,
Page 225.
yeah.
Which question?
Practice problem 3,
When ammonia, that one?
yeah.
Is passed over hot calcium, calcium hydrogen. Okay, so you want what?
The excess reactant.
Okay. So you got the balanced equation, right? And what's the limiting reactant?
What was the, NH?
It's ammonia.
No, sorry, C.
The ammonia is limiting? So you got 20 liters of ammonia at STP and 150 grams of calcium.
Yeah.
So you wanna know how do you find the excess reactant? Well, if calcium is in excess, then you gotta use the ammonia not only to calculate how much calcium hydride you form, but also how much of the calcium you'd use. So you're gonna go from, if ammonia is limiting, you have the moles of ammonia, right?
Yeah.
So that's less than 1 mole. So you're gonna go moles of ammonia to moles calcium to grams calcium consumed. And then you subtract, when you run out of ammonia, you stop using calcium, right? So basically you calculate how much calcium you're gonna use and then subtract that from 150, that's excess. And your answer, when you do the subtraction, it should be that, so the 5's a guess because there's not a decimal after the 150. So, yeah, it should be to the nearest 10 grams, I think, of calcium. I think, yeah. I don't know what the answer is, but that would be how you do it. Every calculation stems from the moles of limiting reactant. Moles of what you can make, moles of what you can use. And presumably if one reactant's in excess, the moles of excess or the mass of excess can only be determined by how much you're gonna use before you run out of the reactant, right? Once you know what's limiting, the rest is just all stoichiometry. It's all stoichiometry. The only difference is finding out what you're gonna run out of. Yep.
On page 169.
One who?
169.
Yeah, it's way back.
5C.
169, yeah, which question?
5C.
5C?
Yes. When I checked the answer key, it didn't include oxygen product. And it was
Nitrogen gas reacts with lead 2 oxide powder yield, lead 2 nitride, and oxygen gas. Okay. So what is the nitrogen replacing? It's a non-metal, right?
yeah.
So it's replacing, has to replace the oxygen.
Yeah.
And so your question is what?
Because when I checked the answer key,
Yeah.
the answer key didn't include oxygen as a product.
So what happens to the oxygen?
I don't
Just disappears?
know.
So clearly the equation's wrong, right? Now, this has come up a couple times in the 2 review classes I just had, and this one, Sherry got some of her students to do these, which is completely unprofessional. Especially if the student doing it's a dumbass. So if oxygen disappears, it would have to be wrong, right? So where'd the oxygen go? It shouldn't have gone anywhere. So you have to produce plus O2. Yeah. The only difference is that oxide as an anion is 2 minus, nitride as an anion is 3 minus. But yeah, the oxygen can't go anywhere. So what they have is, you don't need me to tell you that's wrong if the oxygen disappeared. Yeah, that's embarrassing. I never did that for the stuff I wrote, but I don't know. Yeah.
Just to confirm, these order the products like matter.
What's in front of what? No, A plus B is the same as B plus A. It doesn't matter. Yeah.
On page 219, there's a question that involves like molecules of energy. Will that be on the test?
219.
Question 16.
Which question?
16.
16? That's not a bad question. So, there's only one reactant, right? N2O4. 56 kilojoules of energy is required for each mole of reactant decomposed. How much energy? Okay, well that's just this. There's the balanced equation, right? So there's a 1 in front of that and it's already balanced?
Yeah.
Okay, so for every mole of that, 56 kilojoules of energy is required. Go grams N2O4 to moles N2O4 to energy. That's all. So grams N2O4. So this is just 56. Yeah, 56. There's the thermochemical equation. It's next to a balanced equation, so that means when 1 mole of that's decomposed, that's what you need. So grams N2O4 to moles N2O4 per kilojoule. Well, grams goes here. Mole goes here. You know that. It's 56 kilojoules, right? for mole? Yeah, so it's pretty straightforward. So 28 plus 64, 92. Let's just go to 150. So what is she giving me? 1.25. That's 28, that's 64, that's 92, so yeah, not a lot of energy, because that's a tiny amount of N2O4. It would have been a little different or interesting, because N2O4 is a gas, you could have been given liters in STP and not in moles, but yeah.
Could you do the second practice problem on page
Okay, so in a question like that, ignore the mass that actually forms. That's the actual yield. The stoichiometry gives you theoretical yield, all right? So the precipitate cannot be sodium anything. So it's gonna be barium phosphate. So you're gonna forget the 9.5 initially. So effectively the question is, what mass of barium phosphate can be formed when 15.2 grams barium bromide reacts with an excess of sodium phosphate? Okay, that'll give you theoretical yield. And then divide theoretical yield into the actual yield of 9.5, multiply by 100%, and you'd want your answer to 2 sig figs. Okay? And if you do that, and if your answer doesn't match, assuming Sherry got somebody else to do that question, then we can go through it if you want, but. Mhm.
On page 231, how do you do question 9?
I don't know. 31, number 9. What's the maximum mass of sulfur dioxide gas can be formed from a powder? Well, if you've got 5 grams of each of those, presumably one of them is limiting, right? So, you gotta write the balanced equation. So when you do that, I think there's a pretty big number in front of oxygen. So S8 plus O2. You don't really need states here, but. Here's the balanced equation. So the required mole ratio is 12 to 1, and you could put the 1 on the top or the 12 on the top, doesn't matter. Required mole ratio is in 16 to 1. Required mole or the actual mole ratio, turn 5 grams of oxygen into moles oxygen, 5 grams of S8 into moles sulfur, and decide which is bigger or which is smaller. So if you've done that, which of those two is limiting?
Well, I have my work on a separate piece.
So once you have that, you know you have to start with that, right? So let's say this was question number 1 on the first part of the limiting reactant question. So as soon as you write that, you go required mole ratio equals 12 moles of oxygen for every mole of S8, right? And then you do your actual mole ratio. You're given a mass of oxygen, so you've got 5 grams of oxygen times 1 mole of O2, 32.00 grams. And you've got 5 grams of S8 times 1 mole, I don't know what 32.1 times 8 is, but that would be the molar mass of sulfur. I suspect that oxygen is gonna be limited, but I could be wrong. So take it from there, what do you get? So moles of 2, moles sulfur. They don't do, they do 32.07, okay. ratio works out to 8 to 1, I think. So that means actual mole ratio is less than required mole ratio. So we would go as AMR is less than RMR. O2 is limiting. So it means you already know how many moles of oxygen you have. 0.156, you're gonna go, what does she ask? The mass of the, yeah. So you're gonna put that number here and go that, and your answer should be to 368. And I don't know what it is, but you guys can figure it out. And don't miss this step, all right? I know my writing's terrible, but that's gonna be worth a whole mark. You gotta explain to me why you decided that oxygen is limited. The other thing you gotta be careful, don't put that here. You don't have 8 moles of oxygen. That's just the actual mole ratio. So that's what you actually have, okay? I did that real quick, but I think it's correct. Now, that could have been more interesting if you were asked what volume of SO3 gas could be produced at STP, but, yeah. Find another stupid answer.
The answer, she says this is excess, and then it has a mass, and that says limiting, and it has a mass.
Yeah.
But it asks for the maximum mass.
What is the maximum mass of sulfur? Well, the maximum mass is what you can make when the limiting reactant runs out. So what is it? So did,
Is it 1.04?
what I think the answer might be is, if you had 5 grams of sulfur and all the oxygen you would need, and 5 grams of oxygen and all the mass of sulfur you'd need, these would be the 2 possibilities. It gives 2 answers?
It says excess, and then 12.5 grams, and it says limiting 8.34 grams.
What's the mass of the SO3 you can make? Does it have that as part of the answer? So that doesn't even answer the question. It must have been the same person. Must have been the same person. So you could be forgiven for wondering, what am I doing wrong? Nothing. You're not doing anything wrong. Sherry should have asked that person. Yep.
On page 197, can you go for practice problem 1?
197?
Yes.
Okay. You need the balanced equation, right? So when you get the balanced equation, there's a 2 in front of the ethane, right? But in the information you're given, it's not in a balanced equation. So in the information you're given, that means when 1 mole of ethane is burned, that's the amount of energy released. But in the balanced equation, there's a 2 in front of ethane, which means you'd have to multiply that by 2. So the thermochemical equation would have the balanced equation with the 2 in front of ethane, and then because it's an exothermic reaction, you'd have to write plus 2857 kilojoules per mole on the right-hand side. That's thermochemical, because energy is being produced, right? In the delta H, you still have to write the balanced equation, but then to the right of it, you write delta H equals negative 2 times that, 2857. But then when you write kilojoules per mole, then it means as per the whole reaction. But because you gotta multiply the ethane by 2, that's why you gotta multiply the energy by 2. Okay? And that multiplying by 2 holds for both number 2 and number 3. Okay? Yep.
For question 2 on page 213, it says,
215?
213 is the question 2 is It says there's excess sodium hydroxide at STP, so that's like actually, so why is there as STP?
Yeah, once again, you're right. I don't know why there's two STPs there. So just put your finger over the last at STP. You only need one at STP. Yeah, so sodium hydroxide at STP is irrelevant because it's a solid or it's a solution, but it's not a gas. So I think the at STP is just a misprint. But at STP has to refer to the ammonia, okay? I mean, there's only one gas in that whole equation. And by the way, look at that equation while we're here. If you put your thumb on the right-hand side of the arrow, you should be able to predict products, right? Because that's an ammonium salt plus a base. So when you write that to balance it, put ammonium hydroxide as a product, balance it that way, and then whatever coefficient's in front of ammonium hydroxide would be the coefficient in front of what it turns into, which is ammonia and water. Okay? Yeah.
Can you go over question 3 on page 227?
Question 3? I don't know. On page 227?
Yeah.
When hydrochloric acid is added to 500, write the balance equation. Okay. Now, if we were gonna write the products for this, let's start it as H2CO3, then turn it into water and CO2, okay? So we're gonna make calcium chloride. You don't really need states for that. And then we'd make hydrogen carbonate. So to balance it, two chlorines, two hydrogen, so it's balanced. So this would then decompose into water and CO2, okay? There's the balanced equation. Now, contaminated means impure, all right? So when hydrochloric acid is added to 5.73 grams of impure calcium carbonate, 2.49 grams of carbon dioxide is obtained. Write a balanced equation, find the percentage purity. Well, there's more than one way to do this, but logically, the only thing that can make carbon dioxide is pure calcium carbonate, correct? So the way I do it, I'd go I do this. In other words, what mass of pure calcium carbonate can make that much carbon dioxide? Does that make sense? Now that mass is going to be less than 5.73 because 5.73 was impure. So the question really boils down to what mass of pure calcium carbonate can produce this. Once you have that, you have the mass of the pure compound. You already know the mass of the impure sample. So you're calculating the top, multiply that by 100%. Okay? Once you get this, percent or percentage purity equals mass of pure sample, which you know, you just calculate. That's calcium carbonate. So that goes here. you're given the mass of the impure sample, she calls it contaminated, same thing. Impure calcium carbonate, and presumably this is gonna be less than that. Times 100%, okay? Does the logic make sense there? Okay. Now, the other way you could do it, is to pretend all of this is, the whole 5.73 grams is pure. Calculate the mass of carbon dioxide you'd make if that was all pure. But obviously, the mass of carbon dioxide you could make is gonna be more than what you really make. Then you could divide those two. But this, to me, makes the most sense. And you want your answer to 366. And then check your answer and see. I hope this one's correct. We're 0 for 2 so far. So this is under the heading, the only thing that comes out of a stoichiometry calculation is pure. Okay? Yeah.
Can you go through question 10 on page 232?
Question
10.
10 on 232. In the reaction in question, so I'm assuming she means number 9? Yeah. In the reaction in question 9, 63.2 grams of sulfur trioxide are produced by using 40 grams of oxygen and 48 grams of sulfur. What is the percentage yield? I would not do that. I would not mix. I mean, the way that's written, you're given quantities of 2 reactants, that's limiting reactant. Now, if you do the actual mole ratio, required mole ratio, are they the same for that question?
I'm not sure all of it.
Right, but my point is, based on the way she's asked it, you have to assume that one of those is limiting. Then you couple limiting reactant with percentage yield. I would never do that. No, I'm not gonna, I'll do a limiting reactant question, or I'll do a separate percentage yield, but I'm not gonna expect you to marry the two, okay? That's how you would do that though, right? Whichever is limiting will dictate the mass of product you can make, and that's theoretical. And then obviously, if that's how much you got, that was actual divided by theoretical times 100%, but I'm not gonna put those two things together, okay?
I was wondering if you could also do question 18 on 233.
18? No, that's not fair. A couple reasons it's not fair. It's doable, but if you look back to page 169, see the balancing bonkers at the very bottom there? What's the first reaction in that list? Same one. Is there a way to balance that? Yes. If you balance it by inspection, you can do it, it's just not easy. That is one of those redox reactions where you almost need a systematic rather than inspection to do it. So if you take Chem 12 next year, and I teach it, there are 2 methods that we employ for balancing redox. One is called the half reaction method. One of them is called the change in oxidation number method. The half reaction method would work just fine for that, but we're not doing redox. in this course, so I wouldn't give you that. And oftentimes, when Sherry gets to the end of a section, she'll pick the most difficult or convoluted example she can just to finish it off. That question is not only the end of 4-6, it's the end of the first half of the year. That's like stoichiometry, like squared. So, and plus you're actually coupling two different reactions. So no, I wouldn't do that. It's doable, but I'm not, that's not the point of a test. And she wouldn't put that on a test either. That would be one of those, if you got nothing but time and maybe you want bonus marks, good luck. But you guys aren't gonna have extra time on this. I'm just gonna, hang on, tempt fate and see if any of the admin team actually did talk about it, which I doubt. Oh, look. Yeah, we're gonna be keeping a late start, which just means he didn't talk about it at all. That's awesome. Therein lies, gee, maybe it is time to retire. Anyway, so, yeah, definitely ask your teacher. And one of you get back to me regarding the F1 we can take care of, but the H1, you're gonna have to get there late, all right? But don't say it that way, ask really nicely. What else?
If it's a neutralization reaction, do we classify it as a double replacement since it's a type of
No,
double replacement?
classified as neutralization. Yeah. Now, for the precipitation one, you can just leave it as double replacement. For the third type, double replacement producing water and gas, okay? Yeah.
For the neutralization reaction, we have to identify if it's a binary or a complex salt.
For a neutralization reaction? No, it's just a salt.
Okay.
And by the way, you won't have to predict synthesis for ternary salts. In other words, a metal oxide plus a non-metal oxide.
Mm-hmm.
You won't have to predict synthesis or decomposition for non-metal oxide in water, because determining the acid you produce would mean you'd have to work out the oxidation state of a non-metal, which you're not going to have to do. And so you also wouldn't have to predict the decomposition of that acid.
Okay.
But for metal oxides in water, yes. Because metal oxides in water make bases, and then decomposing bases make metal oxides in water. So that one you should be able to do. But anything that requires assigning an oxidation state, no. So don't worry about 4-3 at all. Yep.
For the question that we did on the board, the answer key says it's 98.9%, but when I did my math, I got 98.89.
It said 98 . Did you carry an extra sig fig through to the very end?
No, I didn't. I rounded to 3 sig figs when I got my.
Don't round at the beginning.
Don't round at the beginning?
No, round at the very end.
Okay.
If you round at the very end, it'll probably be 98.9.
Okay.
But that's just a rounding error. You're still doing it right.
Yeah.
Okay? Yeah. But yeah, the rule of thumb for rounding is you can tell by looking at it when you start what your answer has to be in terms of sig figs at the end, but carry one extra sig fig through in the calculations, and then at the very end, round it to the right number. If you round it early, it often introduces some error, okay? That's just kind of a rule of thumb. Yep.
Do you want us to round like the AMR and RMR to sig figs?
No, those aren't, that's not really a sig fig issue. As soon as you know what the limiting reactant is, that starts your sig fig kind of analysis. Yeah. And the AMR and RMR are not gonna be close anyway. It'll be really obvious what's too much and what you don't have enough of. All right? Yep.
On the lab, the first reactants were copper and oxygen. We're wondering like if it's copper 1.
Copper 2.
Copper 2.
Yeah, it'll be copper 2 for reaction number 1 and iron 2 for reaction number 2. Okay? Now, for reaction number 1, did that catch on fire and keep itself going? No. So it wasn't exothermic, was it?
For the lab report on data and observations, do you want us to just say see data tables located on the back of the lab report, or do you want us to also write out like our observations?
No, you can say, if that question is answered in your data table, you can write C data table. But if it's something that maybe isn't on your data table, then answer it. Yeah, yeah. And again, make sure all the reactions are balanced. That seems silly, but some group's gonna give me reactions are balanced. And make sure that states for everything is there. If you're not sure what's a precipitate or not, go to page 363. For the questions, not the follow-up, but the regular questions, all of those should be answerable by going directly back to your data table. For the follow-up questions, you might have to do a little bit of research. For example, the test for hydrogen gas is not a glowing splint reignites. That's a test for oxygen gas. Hydrogen gas is different. And if you're not sure, look it up. What's a positive test for hydrogen gas? We could have done it, but I didn't want another Bunsen burner going that didn't have to. So you don't hold a glowing splint over the test tube, but you do hold something. But you guys look that up, okay? Yeah.
So the manganese dioxide, whatever the black powder was, because it's a catalyst, do you want like?
Put it over the arrow, yeah. MnO2, just put it on top of the arrow. Yeah.
For the question you said before about the positive test for hydrogen gas, on my lab report, do I just say like after some research, this is
You don't have to say after some research. I'll know it was after some research because it isn't in your book.
yeah.
But yeah, the positive test for hydrogen would be do this. And if you hear this, it's hydrogen.
Yeah, okay.
That's, yeah. Any more questions? If any surface between now and Thursday, this is the only room I teach in. If I'm not here, I'm usually in the science office or trying to understand downstairs what the admin team is doing. But I don't usually spend a lot of time talking to them. And be as specific as you can. Usually little questions solve little problems, but little questions left unasked create big problems. And I had to say that several times in the parent teacher interviews. If you're wondering about anything, if anything doesn't make sense, ask me. I get paid for it. Not well, but I get paid. Don't send me an email at midnight on Wednesday night and going, gee, could you explain stoichiometry? Because I won't. I probably won't even reply. Ask me when I'm here. I usually get here at 8. find me at lunch, find me at recess, whenever, but find me. So do that tomorrow if anything surfaces between now and then.